Okay. And this is graphing sine and cosine functions. Okay. So what we're going to do today, like it says up there, we're going to graph the sine and the cosine. You're going to learn how to graph them. And then we're going to learn these things that are new to you, which are called the period and the amplitude, okay, and how to find those two things. All right, so let's begin. Number one. Let's do the sine graph. And here's what I want you to do. Try to mimic this as close to my graph as you can. So do this, and then make this right side a lot longer than the left side. That's intentional. And we're going to put 8 tick marks, 8 slashes. Don't put them too close. So like this. 1, 2, 3, 4, 5, 6, 7, 8. But don't number them, okay? Just slash them like that. And then only one to the left, like that. And then up and down, just 1 and 1. Just as close as you can. I mean, it doesn't have to be exact. This will be 1, this will be -1. But don't number the x-axis yet, okay? And then skip a little space, and number 2, we're going to do cosine down here. So if this was a computer, try to copy and paste this again down here for cosine, okay? So try to make it the same size as you can. So right here, again, you're going to have 8 tick marks, 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then up 1, down 1. Okay, if you have a unit circle with you, take it out, please. If you don't have one, it's fine. Okay, but if you have one, take it out because we're going to use it. I have it on here too, and I'm going to go up to it, but it's better if you see it with you right there. Okay. Okay. Okay, guys, so here we go. One of the major differences, okay, you've never done this before, or you never seen this before, is that we don't count. That's why I didn't put 1, 2, 3, 4, 5, 6. We don't count by 1, 2, 3, 4, 5, 6. We use radian measures, okay? So to graph trig functions. So remember, you have your degrees, right? The radians, okay? And what we do is we could count by 45s or by 90 degrees, but we're going to count by every 45 degrees. So the first 45 degrees is pi over 4. That's going to be the first tick mark. And then another 45 degrees would be pi over 2. That's going to be the second tick mark. And then another 45, and so on and so on and so on. Okay, so I'm just explaining it because I don't want to keep going up and back. So this one will be pi over 4. Can I borrow yours real quick? This one's negative pi over 4, because that's like if you go backwards. That's why it's in the net. Like if you go backwards on the circle. Okay. And then pi over 2. And then another 45 degrees would be 3 pi over 4. And then pi. Bless you. Right there, we've gone halfway around the circle already. Okay. And then 5 pi over 4. And then, bless you, 3 pi over 2, 7 pi over 4, and 2 pi. Now, know what? Bless you. What some of you might be thinking is like, I don't want to graph it by hand because I can just plug it in the calculator. Yes and no with these, because your calculator doesn't count by radians. Okay, so you can't, it's not going to look like this. Decimals, you can make it look like that, but there's TIs that you can't get them to look like, say, pi over 4, pi over 2. Okay, we're going to do the same thing, but instead of doing every 45 degrees, just to be more efficient with our time, let's just do every 90 degrees. So on cosine, I'm just going to do the 90 degree one. So pi over 2, pi, and then what's this one? 3 pi over 4. Is it 3 pi over 4? I think. Yeah, no, 3 pi over 2 though, right? After 3 pi over 2, and then 2 pi. You can put all of them if you want, but those are good enough. Okay, guys, now here's how you graph these. Okay, so remember sine, okay? Sine is you look at your unit circle, is it the x or the y value? The y, okay, so just remember that. And if you're like, what are you talking about? It's what you did on your test, okay? Remember we had 3 of those questions? So right here at 0, okay, there's my x value, there's my y value, right? So at 0, the y value is 0. Okay, so right here on my graph, at 0, the value is 0. There's your first dot. Okay, I'll do a few with you, and then let's look at pi over 2. What is the y value at pi over 2? 1. You see it? Oh, no. 1, right? You'll agree? Pi over 2, y value is 1. So we're going to put 1. Okay. At pi over 2. Okay, I don't want to scroll up and down, so I'm going to depend on you guys that have the unit circle to answer out loud, okay? Because I don't want to waste too much time. At pi, what's the y value? At pi?
0.
0? Okay. At 3 pi over 2, what's the y value? Negative 1. And at 2 pi, what's the value? 0. Okay, let's connect these dots. Okay, ladies and gentlemen, this is the sine function. And that's what it looks like. Okay. Just like on a circle, you can keep going. 720 degrees, 900 degrees. And on this, you can keep going as well. You can go in both directions. And it does go infinity that way, just like you can go in a circle infinity lots of times. But the thing is that after this, it just repeats. It's like the circle. If I go around it, I'm just repeating the circle over and over. So after this, it'll just repeat over and over. Does that make sense what I'm saying? Okay. We don't get, that's the unfortunate thing about like high school math. We don't get into that stuff. But you're like, where does this even happen? Why does this even matter? Electricity, huh? In sound, the sine wave happens in sound. I was going to say in electricity, the way electricity works is with the sine function. Okay, so it happens in a lot of stuff. Okay, let's do cosine real quick. Now you know how it works, but cosine is the x value. We're good? Oh, whose is this? Oh, good thing you told me so I don't step on it. Okay, look at, on 0, what's the x value? 1. 1. And you're looking not at the y value anymore. You're looking at the x value. Okay. Cosine is the x value. At pi over 2, what's the x value? 0. Okay. Pi, what's the x value? Negative 1. At 3 pi over 2, what's the x value? 0. Now we could get more dots, but just with these you can see the shape. Okay. And then finally at 2 pi, 1. Okay. And so here, ladies and gentlemen, this is the cosine function. Okay, that's what it looks like. Again, if you keep going around the circle, it just repeats. Or if you go left, it repeats. Okay. Do you guys think they look kind of the same? A little bit, no, maybe? Okay, let me show you. Check this out. Okay, right here, the red one is the sine function, because the sine function starts at 0. The green one is the cosine function, because it starts at 1. Don't they kind of look the same? Okay, as a matter of fact, if I shift the cosine function over, they're exactly the same thing. Okay. They just start at different places. Okay, so they're very similar. And so let's highlight that difference. Cosine starts at 1. And sine starts at 0. Okay. Because other than that, they look the same thing. They're just a little bit shifted one from the other. Everybody good so far? Yes? Okay. Okay, now let me introduce some definitions or words we use to describe. So this segment of it, from here to here, that's the whole circle, right? That's the part that doesn't repeat. Okay, we call that the period. These are new words, okay? You haven't used these words. We use these words in trig, okay? So the period is you can think of it as the length, okay? The length of it, that's like original, the one that doesn't repeat. Okay? So length that doesn't. Because after that, it just repeats itself. Or if you go to the left of it, it just repeats itself. That's like the original segment, okay? AKA the parent function. Is that okay? Makes sense? Okay. So the period for the cosine function is from here to here. That's the original segment. After that, it's just going to repeat. Okay, so this is called the period. So just like I would say how tall I am, I'm 6 feet. The period of this is like how long is it? It's 2 pi long. That's it. That's what the period is. Okay. Another definition is it's called like the tallness of it, okay, but not from the very bottom to the very top, from the middle to the top, or from the middle to the bottom. Okay. This from here to here, this is called the amplitude. So if this was a roller coaster, like how high does the loop go, or how below ground does it go? Okay, which these are symmetric, so they're going to be the amplitude is the same on top as it is on the bottom. Everybody all right? Good? Makes sense? Okay. All right, let's move on now. So it's important that you know how to do this like this, come up with it. If you plug it in your calculator, it'll make that shape. But it's not going to match up with these because your calculator is counting by 1, 2, 3. Because what is pi? What number is pi really, right? 3.14. So on your calculator, that's where you would see this at 3.14. Okay. All right, guys. All right, so part 3. Let's talk about transformations. You're going to like this because, like I promised you in the beginning of the year, once you learn transformations, they're the same for all functions, including trig functions. So here's what they look like. Oops. A sine b x plus or minus h plus or minus k. We call it the general form, the vertex form, I guess you would call it. You just switch the words here. You could put cosine, or you could put tangent. And we'll do tangent later, but it's what I want to stress is you already know these. What does a plus k do to any graph? Up and down. It's the same for these. Okay, you take that sine function, you just move it up, you just move it down. Okay. The h is the same, right is negative, but it's opposite. Remember, it's the opposite, right? And then left is positive. Okay. The a is still you remember? Yeah, how big? So stretch, and more specifically, vertical. Okay, vertical stretch, vertical compress. Okay. Just a reminder, this is when it's bigger than 1. This is when it's between 0 and 1. And B, I want to be clear with you. B is going to be the hardest part for us because we haven't really focused on B a lot. Like on tests and stuff, we haven't asked you about B. It is the horizontal, and it is stretch and compress. But I will demonstrate again in a little bit how do you tell which one it is. Yeah, but that's what it is. Okay, so here we go. Last part, part 4. We have 2 really small formulas. Okay. So you don't always want to have to graph the graph to extract information because that's just time consuming. So rather than having to graph the graph, we can find the amplitude and the period. We have formulas that we can use so that we can find them without having to graph them. Wish we could graph them, but formulas would be faster. And they're super easy. The amplitude is just the A value and the absolute value. Remember, absolute value, all that means, it turns whatever that number is positive. So if it's already positive, it just stays positive. Okay. And then the period is 2 pi, because remember that's the whole circle, right? Divided by the B value. That's how we determine our period. So 2 very simple formulas. Any questions so far, guys? Nope. Stay with me. It'll be super easy, okay? You'll get this down. Even though you haven't seen it before, you'll get it down. So that leads us to examples. Which I'm going to separate the video for the example.